going to start the second part of this video, or the second video. Here, I want to classify the system of equations, each of these below. I included your notes because I picked that up for a grade and I never returned them to you. So I did the flow chart again over here as a reference so that you can study this portion and kind of memorize what is what. Basically, you have consistent versus inconsistent. Consistent, just kind of like common sense tells you, has a solution or more. So this will have solutions. Inconsistent, just like the prefix tells you, in, means that it will have no solution. If you have an inconsistent system with no solution, but still you have two distinct lines, then it can also be independent. When two lines are distinct, like they're separate, then they mean that they're independent. They're not the same. They're like on their own, so independent. On the consistent side, when you have at least one solution, that means one or more. You can have two different scenarios. Independent would be when, again, you have two distinct independent lines. And dependent would be if you have coincident lines, which are like the same lines. So in the dependent case, you have multiple solutions. And we call it like infinitely many. In the independent, you have only one solution in this case. So first you got to classify if they're inconsistent or consistent. Once you do that, if they are inconsistent, they're probably going to be independent as well, because most of the time, or all of the time, they will be parallel lines. Okay, parallel lines never cross. So they don't have a solution. So they're inconsistent, and they will also be independent because they're separate from each other. So these two go hand in hand. If you do a system and they are consistent, right, that means they have at least one solution. If they are the same line, like same slope, same intercept, then they will be dependent. So consistent and dependent system because they are coincident lines. If they are consistent, meaning you have only one solution, then that means that it's going to be independent because they're going to be two distinct lines. One solution, they'll be intersecting lines. Okay, so kind of make sense of all of this and then go back and figure it out over here. The best way, especially if you don't have a calculator and you can visually see, is to have it in slope-intercept form. In other words, y equals mx plus b. Why? Because in order for me to classify, I need to know what the slopes are, because if they have the same slope, I know that they're going to be either the same line or, parallel, and I need to know the y-intercepts. So over here in the first one, it was super easy. I know that the slope, I'm going to use, I guess, orange for slopes. The slopes here are the same. Okay, so I'm going to write over here same slopes. And then I notice that the y-intercept is different. So I'm going to use green for y-intercept here. If lines have the same slope and different y-intercept, I know that these lines will be parallel. Like we already know that. So this means that they are parallel. If they're parallel, that means that it's going to be a consistent system that is independent because no solution and two distinct lines. So this one right here would be inconsistent and independent. Okay, that's the first system of equations. Next one. Here I run into a little bit of a problem because in slope-intercept form. So that's going to be my first step. I'll move the x over. Okay, and now I see that the slope here is 2/3. This one is -3. Y-intercept is -4, and over here is +5. Different slopes, different y-intercepts. Here I know that this is going to be intersecting lines, which means I'll probably have one solution. Two intersecting lines with one solution. So here I'm going to be in the consistent, because there's one solution, You can solve it if you wish. And independent, because there's two distinct lines. So this one I'll classify it as consistent and independent. So I'm done with that one. Okay, I'm going to go to the next one. This one, both are in standard form, so I got to change them to y-intercept form. So, I'm sorry, intercept. I'm going to move the x over, and this one, so I'll rewrite it over here. Negative 8y equals to 6 plus 6x plus 6x. 6x minus 40. Still don't have y alone, so I have to divide by negative 8. This I can simplify it, so it becomes a negative 3/4 x, and then 40 divided by 8 would be 5. I'm going to do the same process with this one. It's 3x. By the 4. When I switch them to slope-intercept, I notice that the slopes are the same, and I notice that the intercepts are the same. Same slope, same y-intercept. Okay, if that happens, that means that they are coincident lines. So I'm looking at a consistent system because I have at least one solution, and dependent because they are coincident lines, many solutions. So this is going to be consistent, dependent. So I have my three classifications. Again, the first one was inconsistent, independent, because we had parallel lines. This one we had two intersecting lines with one solution, so consistent and independent. And on this one I had same slope, same y-intercept. They were the same exact line, so coincident lines, consistent and dependent because they are the same. Okay, I'm going to move on to the next page. The next page we have to interpret, and this was the Roy-Travis graph that we went over several times when we were studying systems. So now I have the graph of Roy and Travis, and I need to interpret the solution. So first of all, what is the solution? Solution is when two intersect, so it would be right here. So I find my point. My point would be 4 on the 170 on the y. So in order for me to interpret a solution, I need to know what each of them mean. So in this case, the x is hours, and the y is distance from Dallas in miles. So now I'm ready to interpret. So I'm assuming here that we're doing miles per hour on Roy, right? The slope would be in miles per hour, and Travis miles per hour. So I'm assuming they're traveling, right? Distance from Dallas, they're traveling away from Dallas, and at 4 hours, both of them are 270 miles from Dallas. So at 4 hours, both Travis and Roy are 270 miles from Dallas. Here you can extend it. They meet each other at that point. Okay, so that's where they meet each other. Okay, that was the interpretation there. Put it in coordinate points, figure out what each means using your graph. This is hours, this is miles. Put it here and then write it as a sentence, looking at all the graph and what it means. Over here it says work with a partner. Ignore that part. You're working on this by yourself. Okay, here they're talking about a drink and a sandwich for $4.50. Your friend purchased a drink and 5 sandwiches for $16.50. And here's a part you want to determine the price of a drink and the price of a sandwich. Okay, that's what you're looking for. This is an equation, not an inequality, and we did a lot of these during class. So I'm going to name the first thing X, the price of drink, and Y, the second thing that was mentioned, would be the price of sandwich. Okay? So here, purchase a drink and a sandwich. That means you purchase one of each. So if I purchase one drink, I would multiply that times the price of it to know how much I paid for that. And 1 times the price of the sandwich to know how much I paid for that. And when you bought those two together, you paid $4.50. Okay? Then, this time your friend purchases a drink, so still one drink only, times the price of the drink. 5 sandwiches, so 5 of those times the price of the sandwich. And this time it was $16.50. Once you have this there, now you can decide if you want to do substitution or elimination. It's up to you. I feel like I'm going to do elimination. Let me rewrite my 2 equations over here. Okay, I want to eliminate over here. I'm going to eliminate the X first. Okay, they already have a coefficient of 1. So I can either make the top one or the bottom one, multiply it by times -1. I'm going to do the top. That way I can make both of these be -1, so I can zero them out. Okay, so I have to multiply all of it by -1. So here I would get, and I'm going to rewrite it over here, -1x minus -1y equals -450. This one stays the same. I don't need to change it because here I have my 0 pair. Okay, so from here, now I'm going to eliminate what I wanted. I have my 0 pair on the x's, so they eliminate. And then I have 4y equals. Here, be careful. A lot of you notice like, oh, okay, I have a negative and a positive, so I'm going to subtract. And I notice a lot of little errors where you start subtracting like here where you are. Remember, you still have to write the 1650 first and then the 450. Okay? Don't subtract like this, how they are. This one's smaller than that one, and then you get like a weird number. Okay, so make sure that you do this on the test. So it's $12. Here, this one's smaller than that one, so this one wins, so it stays positive. And you don't have to put the decimals. I'm just doing it because it's in dollars. So now I know that the price of the sandwich is $3. Once I know one of them, I can use any equation to go back and see what the other one is. So in this case, I'm going to use that first one, the 1x plus 1y equals 450, like the original equation. Now I know y is $3. So I'm going to go back and substitute it in here to figure out what the x is. So now I'll do 1x plus 3 equals 450. And don't forget the decimals here. If it doesn't have any, that means that it's a whole number. So be careful there too. Okay, so when you're done with that, then now you have the 2 answers. The price of the sandwiches and the price of the drink. Just to be super sure, you can go ahead and use any of the equations and make sure that you did it right by checking it. So I'm going to use this one. And then you're going to substitute in your answers. I got that x was 150 and I got that y was $3. So I'm going to make sure that it equals 1650. This is my check right here. Okay, so 150 plus, that's 15. and that does give me 1650. So now I'm super sure that I did this correctly. Okay, so y, the cost of the sandwiches is 3, and the cost of the drink is 150. Okay. All right. Last problem is to graph. If I'm going to graph an inequality, okay, I can do two things. I can get the intercepts by making y be 0 and finding out the x, and then x be 0 and finding out the y. I can also change this to be slope-intercept. I'm going to go for that. I'm going to make this be slope-intercept form. Okay, and this is my y-intercept where I begin. So I'm going to make it be this way. So I'm going to solve for y. Do plus 2x to move it over. And there you go. I'm done. I didn't have to do anything else. Okay, so now I know that my slope is 2. I'm going to make it be a fraction. If it's a whole number, to make it be a fraction, you put it over 1. Both the 2 and the 1, like the 2 is positive, so this would be up and to the right. And then where it all starts would be your y-intercept, your b, which in this case is 8. So I'm going to start with the 8 first. So here is my y-intercept, my y-axis, and at positive 8, I will do my dot. Okay, and then here I'm going to do up 2 and to the right 1. So up 2 to the right 1. Like 1, 2 to the right 1. Now I'm done. Like there's no more graph. So like, oh man, how am I going to get a nice line from here if it's just like super close? Remember that to get positive 2, you can also do negative 2, negative 2, negative 2, and negative 1. That's also positive 2. So in other words, once you do up 2 to the right 1, you can reverse it. Like down 2 to the left 1, down 2 to the left 1, okay, down 2 to the left 1. You can also do that. Reverse the process on the other side. Okay, if you went up to the right, you can reverse it down to the left and still get a positive slope. Now here I'm ready to graph. However, I remember, hold on a second, this is an inequality, so I got to pay attention to the sign. The sign is less than. So y has 1 cookie and the other stuff has 2. So this is less than. Less means that I'm going to shade below. And it also has or equal to. So that means that it's going to be a solid line. So now that I'm prepared to do that, I will do my line. This is my boundary line. And I'm going to shade below. So below would be on this side. If you're not sure where to shade, pick a point. I decided I'm going to shade over here. So a point over here where I decided that I'm going to shade would be like 0, 0. You can try it and make sure that this is where you're going to graph. So I'm going to go over here and I'm going to try this equation and see if 0, 0 works. If it gives me a true statement. 0 is less than or equal to 8. Yes, that is true. So yep, I'm good to go. If you would have tried something over here, it would have given you a false statement. Graph would look. Okay, and that concludes our video for the unit review.